All right, guys, in this unit, we're going to be learning some techniques of integration. How do you deal with some tricky integrals? There are a lot of things you cannot do the integral of, and we'll see that today, but there are some things that you can if you know some tricks. So today, we're going to be learning something called U substitution, which is a technique to do the reverse of chain rule. So if you do the derivative of f of g of x, the chain rule tells us it's going to be the derivative of the outside with the inside left alone times the derivative of the inside. I'm going to rewrite this slightly differently. What if we have the derivative with respect to x of f of u? If we call g of x u, then the derivative is going to be f prime with u left alone inside times the derivative of whatever u is. So this is another way to think of it using the letter u, which we'll be using today. So how do you do the integral? Well, if you have the antiderivative of the derivative of something, could be a function, and it's multiplying times the derivative of that inside function, this is just f of u plus c, right? So if you've got a derivative of u and you have the derivative of that inside function, this is the reverse of chain rule. So let's see it. Before we get into the examples, I just want to show you what this means. This means that we can actually do a lot of integrals that maybe we didn't think we could do. Let's say we have cosine of x plus 4. Well, this isn't just cosine of x, and so it is a chain rule thing. But what's the derivative of x plus 4? The derivative of x plus 4 is 1. And so if you want to do the integral, it's just going to be sine of x plus 4, because when you do the derivative, it's going to be cosine of x plus 4 times this derivative of 1, which won't even affect anything, right? We will always be able to do something like the integral of e to the 7x. Even though this isn't a just e to the x, it is a chain rule thing. Because the derivative of the inside is a constant, we will always be able to like mess around with the constants by just undoing it. Where we will run into trouble is if the derivative of the inside is a function. And then we'll need to have that there. So let's look at this. Here, I'm going to think of this like if you have a function inside of a function. Here we have x squared plus 1 is inside of x to the 4th. So the inside function, we're going to call x squared plus 1. And that's going to be u. We're going to call that u. And what we're always going to look for is, do we have the derivative of that inside function? What's the derivative of x squared plus 1? That's 2x. And so here we have the derivative of u. And so this is the integral of, I'm going to call this u to the 4th, and I'm going to move this to this side, times, a lot of times we'll write this as du instead of u prime. So integral of u to the 4th du. So we'll put du, right? And great, so that's cool, and we have it. This means we can do the integral. Once we've substituted it, this is u to the 5th, and we raise the power by 1, and we divide by 5, and the du is just going to go away. We need a plus c. And then we're going to go back and we're going to plug back in what the u is equal to. This is 1/5 x squared plus 1 to the 5th power plus c. So u was x squared plus 1. And this should make sense, guys, right? Like, this is just chain rule. When you multiply by 5, it'll cancel out the 1/5. You'll lower the power by 1. You'll get x to the 4th, x squared plus 1 to the 4th. But then you'll have to multiply by the inside function. And that's what this was right there. Another way to think about this is, okay, you know when you do the chain rule part of it, you'll have to multiply by x squared. So what some people like to think of this as is instead of using u substitution, you just say like, hey, you know what? When I do the integral, it's going to be x squared plus 1 to the 5th. And I'm going to have to divide by the derivative of this. So you just like divide by 2x. And if it cancels out all the x's, it's going to end up working. If it doesn't cancel out all the x's, it's not going to work, right? So you don't have to do u substitution. You can kind of skip it. And I'll show both those methods as we go through this. So here's one for you to try. What is the inside function? What should we use as u here? U should be hopefully we can see that x cubed plus 1 is inside of the square root. So u is x cubed plus 1. And what is the derivative? What is du? What is the derivative of u? Well, the derivative of u is 3x squared. We multiply by the power and lower the power by 1. And look, we've got it there. There it is right here. So this is the integral of the square root of u du. Here's the du. And of course, we want to write this as u to the 1/2 power. So when we do the integral, we raise the power by 1. So add 2 halves. That's adding 1. And divide by the power. Remember that dividing by a fraction, you multiply by the reciprocal. Plus c. And then we substitute back in the u. So 2/3 square root of x cubed plus 1 cubed. So I also rewrote this as the 3/2 power is square root cubed plus c. So there we go, guys. That's how it works. I want you guys to try this one on your own. And hopefully you saw that the inside function here, the u, the inside function is sine of x. And so then the derivative is cosine of x. And look what we had there. This is e to the u times du. What's the integral of e to the u? Well, it's just e to the u plus c. The integral of e to the x is e to the x. So the integral of e to the u is e to the u plus c. And when we plug back in the u, this is e to the sine of x plus c. And this is how we should write our answer. Now, I just want you to see, going the other direction, this was an antiderivative. Do the derivative of e to the sine of x. The derivative is e to the sine of x. We do e to the something, is the derivative is going to be e to that something. We don't change the inside function, times the derivative of sine of x. That's what the chain rule says, and the c will go away. So we get cosine of x, e to the sine of x. I want to make a quick plug for the other way of doing things. You know, another way of thinking about it is, hey, this is a chain rule thing. The derivative of the inside is cosine of x. So you can just divide by cosine of x. And if it goes away and it's just whatever, you can just like do it directly. So the integral of e to the sine of x is e to the sine of x. And we already took care of the chain rule part. So you can do it without u substitution as well. All right, one last one to try here. What is the inside function? And this is a little tricky. What is the inside function? And you might have thought it was secant because secant is getting squared. However, if we had said u was secant of x, then du would be secant of x tangent of x. Do we have secant of x tangent of x? Not quite. We almost do because of this 3. And in fact, there is a way to deal with it. It just becomes tricky. The better choice, in fact, I'll show you it in a second. The better choice is u is tangent of x plus 3, because then the derivative of it is secant squared, which is right there. So we have that derivative here if we call this u. Okay? So go ahead and finish it from here. If this is u, then we've got the integral of u du. And how do we do the integral of u? Well, this is just the integral of x is x squared, and we divide by the power. So 1/2 u squared plus c. And the u was tangent of x plus 3. So 1/2 tangent of x plus 3 plus c. Oh, squared, sorry. Now, I do want to show you there is kind of a tricky way of doing this if you multiply it out. So if you get secant squared of x tangent of x plus 3 secant squared of x, we can just do this integral. This is just 3 tangent of x, right? And this one, there's actually 2 ways of doing it. You could think of tangent of x as u, right? So this could be u, and then the derivative would be secant squared, so no problem there. Or you could think of secant of x as u, and then du would be secant of x tangent of x. And if you rewrite this, you actually have that. This is secant of x, secant squared is secant of x times secant of x tangent of x. And so this is your u, then this would be your du. And so you can do the integral by saying, hey, this is my u. And so it's going to be 1/2 of u squared. And then the du will go away. Plus 3 tangent of x plus c. And what's interesting is that this looks not at all the same as this other one, right? Like our other answer came out differently. And the difference is that it's actually just a different c. So these are actually both the same function with a different c. Let me actually, sometimes when you're doing integrals, you can get things that look wildly different from each other, and it's because they have a difference. See, I just want to show you this real quick. So if we have 1/2 tangent of x plus 3 squared, and we have 1/2 secant, which is 1 over cosine. Oops. Oh no, that's not what I wanted. 1/2 secant is 1 over cosine squared plus 3 tangent of x. If we graph these without the plus c's, what you'll see is that here's the first one. Oh no. What did I do wrong here? Cosine of x. Is it mad at me? Oh, it's because it tried to divide this. Okay, that's not what I want. I wonder if I can make it like this. Will it be happy with it now? Maybe it will. So here's tangent of x, and here's the secant one. And you'll notice it's like the exact same graph, but slightly shifted vertically because it has a different c. Be aware that that is a possibility, that there could be more than one way to do it. Hold on, I need to put somebody in a breakout room real quick in my live Zoom class. I apologize. All right, so we got two possibly different answers because they could have different c's. But I hope we can see that what we're looking for is, do you have the derivative of the inside function? Is it a chain rule situation? If you have an inside function and its derivative, you can do the integral. Now, you don't have to have exactly the integral. Clearly, the inside function here is going to be what? X squared plus 1 is inside of the fourth power, right? So this is our inside function. What is the derivative of this? Well, the derivative is 2x. Do we have 2x? No, but we have x. And it's okay if things are off by a constant, because what's going to happen is we're going to end up just dividing by the 2x. So we're going to end up doing the opposite of chain rule and dividing by the 2x. And so x divided by 2x is 1/2. So this is 1/2 u to the fourth du. So if you just divide by it instead of multiplying it, it'll cancel out. The same thing will happen if you have something like I was showing you earlier, if you had e to the 7x. Well, here the derivative is 7, and you can just divide by 7. So this is 1/7 e to the u, right? And so you can do it that way. Whenever it's just a constant, you'll always be able to just divide by it to undo the chain rule. Because when you do the chain rule, it will multiply by 7. When you go backwards, you just divide by 7. Same here. When you divide by it, you need to end up with just a constant. So I want to very quickly show you the difference between these two things. If you have x squared plus 1 to the fourth, and you have it times 2x, this is good. We can do the integral of it because the derivative of this is 2x. If you have x squared plus 1 to the fourth and you have 7x, even though this isn't the exact derivative, when you divide by 2x, you'll see the x's will cancel out and you'll get 7/2 u to the fourth power. And so this is still good. What is not good is if we had x squared plus 1 to the fourth power, because now the derivative of this is 2x, and if you try to divide by 2x, there's still an x left over. So the x's need to cancel out exactly. This cannot be integrated using u substitution because the derivative of this is x's, and we have an x squared here. It needs to cancel out exactly. It needs to be the result of a chain rule. So the way this works is we just do the integral. So the integral of this is u to the fifth. We divide by 5. 1/2 divided by 5 is 1/10. Just multiply the denominator by 5 if you're dividing by 5. Plus c. And so this is 1/10 x squared plus 1 to the fifth power plus c. We always put back in the u at the end. Again, you can skip the u substitution if you're just oh, aha, I need to divide by 2x. So it'll be dividing by 2. And this will be x squared plus 1 to the fifth power. I need to divide by 5. I need to divide by 2. That's dividing by 10. You don't have to do substitution. You can kind of just see what the result, the reverse of the chain rule is, and that goes a little bit faster. Okay, here, what is, let's, before we get into these, let's do some practice on whether you can do use substitution or not. And hopefully you feel pretty good about that. Now, can we do use substitution here? Yes, because if u is the inside function, what should it be? X to the fourth plus 2, then du is 4x cubed. It's okay that this is a slightly different constant. The x cubes will cancel out. And so when we divide by it, this is u to the 1/2 power, and we have to divide x cubed divided by 4x cubed to undo the chain rule, and it'll be 1/4, because 1 divided by 4 is 1/4. And so when we do this, this will be, let's see, u to the 3/2 power, we raise the power by 1, and we divide by the power, so that's multiplying by 2/3, so 2/12. So this is 1/6, 2/12 is 1/6, we need a plus c here, I guess, square root of x to the 4th plus 2 cubed plus c. So here is our simplified version. All right, how about in B? What is the u here? And it might be a little tricky to see at first, but I hope we do see it. I hope we see that the u should be this guy. And it's always, the u is always going to have, if it's a power rule one, the u is always going to have a power 1 bigger than something that's there. So the u is 16 minus x cubed, because then du is, what is the du here? It's negative 3x squared. And we have an x squared here. So when we rewrite it and we divide by negative 3x squared, x squared divided by negative 3x squared is negative 1/3. And we could leave this as 1 over u squared, but really what we want to do is rewrite this as a power rule. This is u to the negative 2 power, right? Remember, this is dividing by something squared is something to a negative power, and now we can just use the power rule. So go ahead and finish this from here. What should the final answer be? Well, we're going to raise the power by 1. We're going to divide by the power, so positive 1/3. Plus c, and we're going to need to rewrite it. So this is 1 over 3. Our u was 16 minus x cubed plus c. That's our answer. Try this last one yourself. What is the antiderivative here? And hopefully we saw that u was 6x, so du is 6. We just need to divide by 6, and we'll be good here. So this is 1/3 cosine of u. We need to do that antiderivative. That's 1/3 sine of u plus c. So 1/3 sine of 6x plus c. Now, again, you could have just been like, oh, the derivative of the inside is 6, so we just divide by 6 to undo the chain rule, and then do the integral and ignore the inside function. So that's another way we could do it without doing use substitution. It goes a little faster. All right, let's practice some different situations. If f prime of x equals sine of 7x, what is f of x? Well, hopefully we see that this derivative has an inside function, and so the derivative of the inside is 7. We need to divide by that 7. This is 1/7 sine of u. So when we do the integral, it's 1/7 cosine of u, but the derivative of cosine is negative sine, so we need a negative sign there, right? Plus c, and u was 7x, so negative 1/7 cosine of 7x plus c. So you can always check at the end by just doing the derivative and see if it gets you back the original one. The derivative of cosine is negative sine, so we'll end up with the right sign. And then you'll have to multiply times the inside. So multiplying by 7 will cancel out with the 1/7, and it will work. All right, here's another one for you guys to try. What is the integral? And hopefully we can see here that the inside function is 4x squared minus 7. So the derivative is 12x. And again, because that 3x is there, when we divide by 12x, we'll be good, and we'll just get 1/4. And this is u to the 1/2 power, right? We always want to get it into a power rule situation. We need to raise the power by 1. So add 2 halves, that's adding 1. And divide by the power is multiplying by the reciprocal. So 2/3 times 1/4, that's 2/12, which is 1/6 again. So we get 1/6. This is the square root cubed. I guess I should have a plus c here. And the u was 4x squared minus 7. So 4x squared minus 7. So we always just substitute back, and we should end up with a function that looks a lot like this one, so that when you do the derivative of it, you get back to the original function. It's a nice check. Does it look like the original one? Like, is the inside function still the same inside function? The inside function needs to be the same inside function every time, because when you do the chain rule, you don't change the inside function. Okay, how about this one? This one's a little tricky to see. Hopefully we noticed that the inside function needs to be sine of x. Sine of x is to the 5th power, right? So it's u is to the 5th power. And then the du, the derivative of sine of x, is cosine of x, which we have right there. So this is just the integral of u to the 5th du. So when we do the integral, we raise the power by 1 and divide by the power. And we need to put back in what it is to the 6th power. So it's sine to the 6th power plus c. Again, looking at your answer, you should be like, oh yeah, I can see that the derivative of this will give me this, because when I do the chain rule, it will work. How about this one? Well, I hope we noticed that this is not u substitution. Nowhere is the derivative of anything the other thing that's multiplying there. Instead, this is one of those ones where you actually have to divide it. So when you divide, you subtract the exponents. This is x to the 1 plus 2x squared divided by x to the 1/2. And when we divide, we subtract exponents. So this is x to the 1/2. 1 minus 1/2 is 1/2. And 2 minus 1/2 is 3/2. So this is not u substitution. Don't get into a place where you think everything is u substitution. Not everything is. This is just like power rule that you had to rewrite. There wasn't a way to do it using u substitution. And there won't always be, right? Don't just automatically start thinking everything is u substitution. It's just when it's the reverse of a chain rule that, that you'll end up, if there's a clear inside function, it's u substitution. So we need to raise the power and divide. Here we're going to raise the power and divide, so 4/5 plus c. So 2/3 square root of x cubed plus 4/5 square root of x to the 5th plus c. So hopefully we feel okay with this. Solve the differential equation. What is the inside function here? Well, the inside function is x to the 5th, because when we do the derivative, we can see we'll get an x to the 4th out right there. So u is x to the 5th, du is 5x to the 4th, and we literally have it right there. This is dy dx equals cosine of u du. Again, you could think of this as dividing by 5x to the 4th, and then it literally just like cancels out when you divide by the inside function. So the integral is going to be y equals, remember, when it's dy dx, we should end up with y equals, right? When there's no dy dx, we shouldn't have y equals. So y equals, solving a differential equation means finding what the original function was. And so the integral of cosine is sine plus c. And u was x to the 5th. So y equals sine of x to the 5th plus c. And I hope you see that when you do the derivative of sine is cosine. We leave the inside function alone, and then we multiply times the derivative of the inside function. That's the chain rule. How about this one? Again, not u substitution, guys. If you tried to make this one u, the derivative of u would be 1, which is not this. If you tried to make this one be u, the derivative would be 1, which is not this. You had to multiply this out. Don't start thinking that everything is u substitution minus 12. So I'm just like multiplying all these things together. So that's what we get. So you just multiply out the binomial, minus 12, and do it regularly. Not everything is u substitution. That's ugly. 1/3 x cubed plus 1/2 x squared minus 12x plus c. Not everything is u substitution. Don't start thinking that everything is u substitution. It's only when the derivative, only when you have a chain rule situation. How about this one? Hopefully we got that here there is a clear inside function, and the derivative of that inside function is basically there. So u is x cubed plus 4. So the derivative would be 3x squared. Now we don't have 3x squared there, but when we divide by 3x squared, the x squareds will go away. And so we end up with 1/3 u to the 5th, right? And so this is du. So this is, we divide by the new power, 1/15 u, oh my gosh, guys, that was bad. 1/18, we raise the power first, then divide by the new power, plus c. And so this is 1/18 times x cubed plus 4 to the 5th plus c. And it gives us an initial condition, so we can actually find what c is. When x is 0, y is -2. Equals, oh, this is going to be really ugly. -2 equals 0, 4 to the 5th, so we get 4 to the 5th over 18. And I'm going to use a calculator here. It's going to be ugly. I should probably change these numbers to be slightly better. I don't know why I haven't done that yet. Yeah, well, I should have, but I didn't. So let's make this be 4 to the 5th. It's going to come out ugly. 4 to the 5th divided by 18. It's not going to come out evenly. And so -2 minus 4 to the 5th plus 18 is going to be this. It's -58.88888. So c equals -58.8 repeating. And so when we plug that in, we get I guess we should say f prime of x, f of x. Oh my gosh, guys, I'm making mistakes everywhere. This should have said f of x, not f prime of x. F of x, because we did the antiderivative. F of x equals 1/18 x cubed plus 4 to the 5th power, and we found that c was -58.8 repeating. All right, last one, and this one's slightly different. So hopefully you do okay on it here. Clearly u is x squared plus 5, that's the inside function, and it should tell you that you're doing it right when the du is 2x, because we've got something x. So something x, those will cancel out. Now when we divide by 2x, 4x divided by 2x, so 4x divided by 2x is 2. So it's 2 times 1 over u, or we could have put 2 over u. Now how do we do this integral? 1 over u is the natural log, so it's going to be 2 natural log of the absolute value of u plus c. So 2 natural log absolute value of x squared plus 5 plus c. Guys, the only fraction ones you're ever going to do, and this is a good thing to look for, is you can only do fraction ones using u substitution if the derivative of the denominator is in the numerator. So the derivative of the denominator will always be in the numerator. It will never go the other way around. So you'll never have to, let's say, like, hey, is the derivative of the numerator the denominator? That isn't how multiplication works. If the derivative of the denominator is in the numerator, then it'll be a u substitution one. So like, look if denominator equals u. So if the numerator has a derivative that has the same degree, so 2x has the same degree as 4x, then it'll be u substitution. Okay, guys, you'll get a lot of practice on this. This is a tricky skill at first. And then with practice, it becomes just, do you guys remember when we were first learning chain rule? Everybody had a super hard time with it. And then after a few days of it, it just like becomes natural. So, you know, again, the big idea is that the chain rule says if you have the derivative of a function with another function inside of it, you leave the inside function alone, and then you do times the derivative of the inside function. And if we think of this as f of u, you leave the u alone and then have the du on the outside. The antiderivative is just going backwards. If you have the derivative of the inside function outside of the function, then you can do the integral by undoing the chain rule. But be careful. If you have something like e to the x times x squared, this is not well, I know how to do this one. You guys don't know how to do it yet because you don't have the technique. We'll learn more techniques. But this is not u substitution because the inside function would probably need to be like u equals x but the derivative would just be 1, and when you try to like divide by 1, it's still got an x squared there, and so it doesn't work. It has to completely cancel out the x's that are there for it to end up working. All right, guys, have a good rest of your day. We are almost to spring break here, so we'll get a nice long rest there. Bye.